Good morning. Thank you for joining today's Research Radar webinar, Savings by Design, hosted by the Minnesota Department of Transportation and the Minnesota Local Road Research Board. My name is Stephanie Tofty. We're excited to have our presenters, Joel Ulring, Dr. Başak, Kristie Billiar, and Chris Sagsveen with us today. Today's webinar is part of the Research Radar series, sponsored by the MnDOT Office of Research and Innovation and the Local Road Research Board. Each month, we highlight research projects focused on a common theme. Before we get started, I will read the Tennyson warning. This session will be recorded for those who cannot attend. If you have enabled your camera during the session, the recording may include your image, which is private data under the Minnesota Government Data Practices Act. You are not required to allow MnDOT to use your image, and there are no consequences for declining to do so. To opt out of the recording, simply turn off your camera. Hey. MnDOT's Office of Research and Innovation manages more than 185 research projects in progress, ranging from local initiatives to pooled fund projects with other states, comprising both basic and applied research. We're here to help transportation practitioners determine whether new research...
10:30, I forgot. Michael put a meeting there.
I think someone's mic is on. We're here to help transportation practitioners determine whether new research is needed or if existing studies may solve your needs, recommend the best research methodology for your project, access local and national funding sources, and manage your project from start to finish. The Local Road Research Board is a city and county-run organization that sponsors research and educational initiatives that address local transportation needs. You can stay up to date with our research by following us online and subscribing to our newsletters. We will send you website and subscription links in a follow-up email following the webinar. We funded 28 new academic research projects for 2026. To see the full list of new projects, scan the QR code on the screen. If you have subject matter expertise on any of these projects and are interested in serving on the technical advisory panel, please reach out to our office by emailing research.dot@state.mn.us.
Yeah.
And now I would like to introduce our presenters. Presenting benefits of preventive maintenance is Joel Ulring and Dr. Başak. Joel has been employed by the Minnesota Department of Transportation since 2013 and currently serves as the state's pavement preservation engineer. He has a bachelor's degree in civil engineering from South Dakota State University. Prior to joining MnDOT, Joel had 18 years serving 3 Minnesota counties and has over 11 years experience in the private sector as a materials, geotechnical, and pavement engineer in the upper Midwest, Canada, Alaska, and Western Australia. Dr. Bektash is an associate professor of civil engineering at Minnesota State University, Mankato. Her research focuses on infrastructure, asset management, bridge and pavement preservation, performance modeling, and engineering economics. She has led funded projects for FHWA, NCHRP, and many state DOTs. She serves on TRB committees on asset management and bridge management and is a member of the FHWA's Bridge Preservation Expert Task Group. Presenting Assessing the Deterioration of Pedestrian Assets is Kristie Billiar. Kristie is the ADA Policy Coordinator in the ADA Unit of the Operations Division of the Minnesota Department of Transportation. She has been with MnDOT for 28 years and worked on bike, pedestrian, and accessibility issues in various roles during her time. Work in these areas has taught her that these topics are a marathon and not a sprint, and that progress often shows up in the questions being asked. And then presenting asset management tools for local governments is Chris Sagsveen. Chris is a licensed professional engineer and project director of safety and research at SRF Consulting. He brings over 30 years of transportation experience, including senior leadership roles with Hennepin County and the Illinois Department of Transportation. Chris specializes in research-driven solutions, asset management, and is passionate about helping public agencies deliver, operate, and maintain safe, effective infrastructure. So we have reserved time after the presentations for our Q&A. So feel free to either plug in a question to the chat, or we will have an opportunity to ask questions live at the end as well. Okay, I will hand the baton on to Joel.
All right, thanks, Stephanie. Joel Ulring here with Minnesota DOT, and I'm just going to do a brief introduction, and then Başak is going to then present the actual research that was done. So, as you can imagine, MnDOT has been very interested in pavement preservation over the years, and recently, in 2020, Kurt Turgeon, who's the state's pavement engineer at that time, championed this project to look into the benefits of pavement preventative maintenance. So that research project was developed to help quantify the impact and benefits of performing preventative maintenance activities on Minnesota's pavements. The research focused on how PM activities increased pavement life, improved pavement condition, and as a result, increased the length of time between preventative maintenance activities. Data for the research was obtained from the department's pavement management system database. The treatment history, as well as historic pavement condition and characteristic data, were gathered and analyzed. So anticipated outcome of the research was development of a set of decision trees for bituminous and the concrete pavements, designed to give the department's engineers and designers in making better cost-effective decisions for PM activities. This included both timing and frequency of the activities, which improved the life cycle costs for the pavements. This leads to lower cost pavements, as you would expect, with higher condition level ratings, meaning smoother roads and happier drivers. Through the typical research procurement process, Dr. Başak Bektaş of Minnesota State University Mankato was then hired to perform the research for us. We're very fortunate to have benefited greatly from your knowledge and expertise with the project. So with that, I'm going to turn it over to you, Başak, to present the research and your conclusions. Thanks.
Thank you, Joel, for the wonderful introduction. We are very happy to have the opportunity to present our findings from this research project today. I would like to also at this point acknowledge the great help, leadership, and the institutional expertise and data that was shared by us by MnDOT engineers. They have been valuable partners throughout, and the technical advisor panel and the project coordinators. So thank you for this opportunity to do this research. As in the introduction, it was mentioned my main expertise within asset management umbrella, bridges. I have done some pavement projects, but when this opportunity came along, the other Dr. Bektaş, since he's a pavement expert, this was the perfect opportunity to collaborate. So Dr. Fatih Bektaş has been my co-PI on this project. He has payment management expertise. He's a payment management, payment and construction materials expert. But I would like to also acknowledge our research team, research assistants from the data science master's program. They help with data collection, analysis. So Priya Chalubina, Jaswant Wankalapalati, Aishwarya Matam, and Neha Sur. So it was wonderful. It's always wonderful to have the ability to work with students in our research. As Joel mentioned, the data was provided by the Pavement Management Unit, approximately 35 years of condition data, along with earlier construction and treatment records. While these records were also provided to us, we didn't really manage to model them really well. They didn't lend themselves as well to this research, as well as the roughness and right quality index. So our QI, for those who may not know, is MnDOT 0 to 5 serviceability index based on International Roughness Index. We worked with 1 mile segments roughly 18 condition records per segment over the time. And in total, the data set covered over 33,000 segments and 700,000 total records, which is a substantial foundation for statistical modeling. With the comprehensive data set at hand, we needed to answer the question, how do we classify Minnesota payment types and treatment histories to identify key payment groups for lifecycle cost analysis? As payments age and undergo rehabilitation, their compositions and types evolve. So most segments in our data set are associated with one or two payment type codes within the data, and the MnDOT abbreviations for these payment types are given to you here. The 7 payment groups that I'm showing you on the screen account for 95% of the data set we got from the payment management unit. So this formed our initial base data set. We also conducted preliminary analysis to identify most frequent treatment types and the sequencing of these typical treatment histories. So the very comprehensive preliminary analysis basically was done with the motivation to build data block samples that will eventually help us model the life cycle, the payment performance in a statistically significant way, so that we can utilize them in a life cycle cost analysis we have confidence in. While we initially attempted to classify preventive maintenance directly from the data, the variability, because there was a question, particularly from MnDOT partners, how do you define preventive maintenance based on data? And we attempted to do that, but the variability in the RQI data made a purely data-driven classification unreliable. Instead, we first defined what I call base service life, not the full one, is the lifetime between two successive reconstruction or rehabilitation activities. Working with MnDOT engineers, then we had some meetings and identified PM treatments as those who are applied when RQI is greater than 3.5, or when the treatment was placed on a major construction less than 5 years old. So both of these, of course, lead to payment still in good or near new condition. For payments with the data organized, we fit viable survival models to estimate time to rehabilitation for each payment type, segmented by their PM history, PM being preventive maintenance, I will refer to often. The sample with payments without PM that you see here, or any treatment between two rehab or reconstruction activities, had over 1,200 records, with mostly asphalt, but some concrete payments as well. When we looked at the sample or the payments that have with PM, we focused on those with 1 or 2 PM activities, which accounted for the majority of the data set. Payments with 1 PM were most frequently concrete doubled, with PM treatments, maintenance patching, joint seals, joint repairs. Payments with 2 PM were mostly asphalt payments with typical crack repair, chip seal, crack fill, maintenance patching, and so on. Here are the findings from viable survival models. I want to highlight a few things from this slide because they tell an interesting story. For bituminous aggregate base, the scale parameter, which is the alpha, which you can think of as the characteristic service life between those two rehab or reconstruction, increases about from 15 years to nearly 21 years with 2 PM applications. This is a meaningful jump. For concrete double, the increase is around 3 years, from about 19 years with no PM to 22 years with 1 PM. The shape parameter, which is the beta, is also telling when beta is greater than 1, the probability of needing rehabilitation or reconstruction increases with age. This is what we expect for any asset, in transportation asset. What is interesting is that the PM tends to sharpen higher values for the ones that have PM, which means that it tends to reach the end of its useful life in a more predictable way, in a concentrated window, which can also provide value for overall planning. But the direction is clear that especially with those with samples with higher observations, we are seeing that preventive maintenance increases service life. This slide visualizes typical Minnesota payment life cycles to illustrate how the viable models feeds into the life cycle cost analysis. The intervals between the arrows to time to PM, so that purple arrows are PMs. As you see, we have rehab or reconstruction as orange arrows. So the intervals between these arrows are coming from our data and models. So with the time to PM, we are looking at the statistical distribution. And with the time to rehab, we are looking at viable models. So each carry the statistical distribution, and within the Monte Carlo simulation we did for life cycle cost analysis, these intervals are being sampled from their respective distributions as we calculate life cycle cost, propagating the uncertainty from the survival models through to the final cost estimates. To translate service life results into economic terms, we use life cycle cost analysis, specifically equivalent uniform annual cost, EUAC. EUAC allows comparison across life cycles of different total durations or on an annualized basis, which matters here because PM extends service life. We conducted Monte Carlo simulations, thousands of iterations, randomly sampling the time to PM and time to rehab, as I showed you. And we incorporated PM construction and rehabilitation costs, which eventually gives us a distribution of life cycle costs rather than a single point estimate, better reflecting the real world variability inherent in payment performance. 8 spreadsheet models were developed for the simulations, which compare life cycles with PM treatments or without PM treatments for asphalt and concrete payments, and in urban and rural settings to also capture that cost variability. Here are the results from life cycle cost analysis for bituminous payments. The annual cost savings from applying PM, as you see, range from $10,000 to $10,600 per mile per year, whether in urban or rural settings, and that comes with an added service life of roughly 5 to 6 years. For concrete payments, the savings are more modest, around $400 to $1,400 per mile per year, with an added service life of roughly 5 years. While these figures may appear modest on a per mile per year basis, they translate into substantial network level savings when applied across MnDOT's full payment inventory over time. A few important caveats I would like to mention. This analysis focused on agency costs only. Having other things such as user costs would even steer the results more favorably through preventive maintenance. User costs, design factors such as traffic loading, long-term performance, and environmental conditions were not covered. As a result, the findings should not be interpreted as a comparison between concrete and asphalt payments. But the core takeaway is straightforward that preventive maintenance delivers measurable cost savings and extends asset lives, and is supportive of the continuation and expansion of MnDOT's PM programs and underscore their importance for sustainable transportation asset management. Here I also list key findings. Some of them I have mentioned. Obviously, we have service life extension from statistically significant models. We have covered economic benefits, which great potential across the network. And I will also emphasize how we defined PM at those new or near a very good condition payment. And research findings enabled the development of enhanced decision trees that we shared with the agency. Some recommendations we provided for MnDOT's future research or internal use We developed enhanced decision trees that they would, of course, filter with institutional knowledge and expertise to adapt to existing guidance. There could be certain pilot programs to address things maybe we didn't have as much data, such as the concrete preventive maintenance, concrete pavement preventive maintenance, and future research could explore some other models. And ultimately, our goal is to have helped agency with certain data-driven tools that can feed into asset management practice. So the question at the heart of this research was, can we prove the payoff preventive maintenance? I think the answer, as I tried to show you today, is yes, at least for Minnesota's payment network and with the data and methods we had available. The full report should be available through the Research Services Office, hopefully in fall. And it's in the meanwhile, Fatih and I are happy to respond to any aspects of methodology or findings, and thank you.
Thank you so much, Başak and Joel. That was wonderful. Next up is Kristie Billiar presenting assessing the deterioration of pedestrian assets.
Good morning, everyone. Thank you for being here today. And as you already said, we'll be presenting on the named research project about the deterioration of pedestrian assets. This research was conducted by Iowa University, and I am reporting out largely from their final presentation and report. So thank you. What we were really trying to get at with this project is trying to get our arms around what has been a long-standing question within the bike and ped community about how fast do our pedestrian and bike assets deteriorate. We really don't have a lot of information at any level in the industry. And as we've been doing more investment, especially from the ADA side, this question has become a little more pressing, because when we talk about compliance at ADA, we're not only talking about the geometrics, but condition is a large factor as well. So you can have a trail that is and sidewalk that is the proper length, but if it's more or less rubble, it is not viewed as accessible. So this is really what we're trying to do and get this conversation started at more of a national level. So we had 5 key steps for this, which was to begin with a literature research and a survey of agencies, just to get an understanding of where we're at. Is this a really worthwhile need? Then we did our, I apologize, these are inverted. We did our field data collection, the processing of that information to create our baseline, and then trying to develop the methodology of, can we actually track deterioration, and the evaluation of that methodology. So our survey touched on, we had responses from 56 entities and 40 unique agencies spanning 25 states and the District of Columbia. So many of them were state DOT, as you can see, but we were able to get a sensibility of what's going on at lower levels as well. And one of the most striking things, if you do work in bike and ped, probably not terribly surprising, is that pedestrian assets are generally found in the planning area. They really haven't moved into the operations place in most cases. And this is part of why state DOTs were answering this, is because as we see TAMs and TAMP type programs evolving in agencies, this need is coming up to the surface. But again, not unusual. We do see this quite frequently. Finding who needed to respond to this was difficult. It kind of sits aside from many of the main agency needs. There is no particular champion for it. And this is a little bit even why in MnDOT, ADA is a little bit of the larger voice about pedestrian, even though we have a fully formed bike and ped office. All of the data states were collecting something, but with the exception of Wyoming, and they are not planning to do so in the near future. And even to give a better sensibility about that gap, user complaints are still our primary understanding of what our system needs. So we don't really have anything routine. So our first piece in that field data collection was to look at what our technologies are that are available and evaluate alternative assessment methodologies. So we did 13 sites that were collected, and this was 15 miles. So I'm just going to take a moment. This is really about the sidewalk portion of the pedestrian access route. We were really trying to, with this process, evaluate curb ramps because those take another bit of effort. So you can just see where we were, largely in the metro and a few in South Metro. Did not get to the northern sites. Our decision was to use a bike-based data collection for collecting the information on pet assets. So this is a data bike that has actually been used by Iowa for trails in the past. They have a really good system for doing that. It's equipped with iPhone, GoPro camera, and 360 camera. So it gives us a sense of the wide view, kind of that roughness, the sensibility, and the 360 camera really functions as that LiDAR piece as well. So what's going on around it. And this is just something that we have also found in the past. There's been a real push for us to collect this information from LiDAR, but unless you're doing a vehicle that is dedicated to that particular route and corridor, it's very hard to get information about the PED assets from the center line. It's because you have parking in the way and you get a lot of distortion in that collection process. All right. So this was our historic baseline that we were trying to identify, finding some other gaps in data, and mostly that came up in the form of gaps in the existing system, so places where sidewalk might be missing. Condition assessment, it was largely a visual assessment, and then trying to get that inventory of distresses. Where are things cracking? Where are they heaving, interrupted by vegetation? And the delineation of pedestrian asset management sections became our next piece to calculate distress density and identify sites where condition had changed. So I won't walk you through all of this, but we went from inputs, data enrichment, aggregation, summary, and the deliverable. So this will be that last piece. We just finished this piece. So in our field data, what we conditioned by visual inspection, we were able to get a fairly decent correlation. So under 0 were viewed as excellent, and anything over 0 was on a scale considered poor, with 0 being essentially neutral, probably about midway in its life cycle. At this point, we're now trying to develop a framework methodology for the statewide for the deterioration of pet assets. So, and we're looking for at least 2 data snapshots collected in the same way. This was a big requirement and a driving force behind how we were going to select what we would do for our deterioration model after the baseline. So we had to find a way to identify a high resolution imagery, extract the sidewalks from that imagery, give it a segmentation so that we were doing things consistently, calculate those image reprocess the data, and then calculate a rate of deterioration. Spoiler alert, we did figure this out. We actually have a very good proof of concept. So our data source selection, we looked at all of these, Google Maps, Earth, MnGeo, LiDAR, and AIP. And we ended up going with MnGeo aerial, and for a variety of reasons. Mostly, it's largely consistent. We collect it in the same way. Being under MnGeo, it's also readily available. Using a lot of other systems like Google Maps, and that would extend to the Microsoft products as well. Those are only available as a point in time. There are little variations that make it very difficult to do the digitizing of that information. So we were looking for surface reflectance and texture analysis. That's going to get what's going on with our sidewalks, what's happening with those cracks. And then we again, with MnGeo, we were able to get high resolutions at a couple of scales. So again, a very worthwhile approach. So facilities were consistent on uniform data collection. It also integrates very well with GIS, which is how that baseline was collected. So you're really getting an excellent comparison. And it also creates a measure of automated and semi-automated analysis. For anyone who's been involved with the collection of pet assets at this time, it is a very labor-intensive process. And when you're trying to calculate density, or deterioration, it's not reasonable to be going out every couple 5 years to figure out what's going on. So this is part of how do we automate it? There are some limitations with the aerial imagery that had to be overcome. Shadows and lighting variations, shadowed artifact heavy images, and aerial imagery lacks that three-dimensionality. So that was one of the pieces that we did sacrifice. So this is our high-resolution satellite imagery, and it allows us to do a network level of collection, and it's a high-resolution satellite imagery, so you can see below. So the next was really just doing a sidewalk extraction from those images. And this was a much cleaner way to do this. Again, you aren't dealing with vegetation and all of that variance, and you get very clean polygons to do that. So, and then the next piece was to take those polygons, segment them down further to 0.01 mile segments so that we could really get a detailed variation in the surface conditions, because the longer a section that you do, the less accurate you are. So it was adaptive segmentation. So we really were adjusting it dynamically and with an environmental complexity. This is a little bit of why we also needed to know what was going around it. And then the attribute assignment, we said, this is a sidewalk, age, trying to get some foot traffic, proximity to trees, vegetation, and other very environmental factors. So we're trying to get a little bit of context to that asset as well. So our sample extraction just walks through. So this first is our basically identifying the polygons and then getting down to that. Okay, this is where we are on the right. And then the image with the little hash marks are the 0.01 mile segments. And what is that looking like? So this is then that final how it would show up on your mapping. So the image properties, we needed to calculate surface intensity. So we looked at surface reflectance data, which was the reflectance of different, basically shows the cracks. Our statistical metrics were standard deviation for measuring surface roughness and variability, the mean, the median, and this resulted in what? A DN, or a digital number. That digital number is the pixel brightness value in satellite or aerial imagery, and it represents the intensity of light reflected at a surface point, from a surface point. So that becomes a weighted average with ranges from 0 to 225. The higher DNs represent a better condition asset, and lower DNs are a worse condition asset. So this is just a very quick example of that. So doing a sampling from 2020, 2022, and 2023. These are the various images. So the 2020 image is showing something that's getting close to faster rates of deterioration. By 2022, we are almost completely deteriorated, and 2023 represents a reconstructed segment. And that was one of our considerations when we were doing that initial field gathering of data, is making certain that we were able to look across time to something that had been reconstructed. So we did basically had to run through and pre-process and clean all of that data. As I said, there are artifacts in that, so we had to really work in the base aerial images. So we needed to make certain that we could do that. And that's where the comparison across the multiple years. And then the mean median difference in the threshold is the difference between the mean and median to identify the year where shadows or vegetation may be skewing the intensity values. So we are able to track that over time. So multiple years, then we calculated the slope, which is our trend line of the rate of deterioration, and then we correlated the intensity to actual field collection data to create a reference baseline. So we did that. We applied this model then to 12 sites. It was 171 sidewalks representing 1,514 segments. So we were entirely located in Hennepin County and Dakota County. And this is what that scatter plot looked like for that information across the various years. So what is that DN? And then it plots out to a deterioration rate. So generally we're looking very high, but we do have consistent deterioration across the years. So it is something that doesn't necessarily have a sudden event, but we do need to be mindful of what is that deterioration rate, and should we be doing any intervention, and what does that get us, if anything? So generally, we saw a pretty consistent deterioration of 2.63 negative. So that was reasonably helpful. Systematic filtering eliminated 90% of the anomalies. So this is a pretty clean method. And we were able to see that we could be predictive about this. So we now have a good understanding of what we will typically see in our system. The goal is really to hopefully reduce construction savings by seeing if we can do any early detection and do some interventions, if it's panel replacement, any sort of things of that nature. Improving the life cycle cost of the total asset by making certain that we are doing incremental fixes versus having to wait until something is reconstructed. That also helps us manage our liability under ADA. And hopefully to reduce risks, not only with the trip and fall standpoint, but also with our ADA liabilities. And it is a relatively reliable mechanism for risk management prioritization. So this does feed nicely into the TAMS models. Safety enhancements, being able to recognize right from the jump. Okay, this is going to be an issue and we don't have a project until X number of years away. So it can be far more dynamic because typically, or rather historically, our management of PED assets has been, we're doing a reconstruction project, now is the time we'll address our sidewalks. And that's been true from state down to cities and counties. And then the other is anticipated benefits, a little bit on the lower side, but the environmental benefit can be that we aren't having to mobilize as frequently, and we are using our materials more effectively. All right, so from there, we are probably ready to go into starting to deploy this a little bit more. We do need to develop some training. We are also waiting for the completion of another project called SARC, which also piggybacked off of this work. So those two have been in interaction. They have developed some training as well, and we're really trying to test and see what is our best model and approach, and how do we make it available beyond the state. So that's where we are now. And I think I've kept my time, so I will send it off.
Thank you, Kristie. All right, and that was assessing the deterioration of pedestrian assets. Next up,
Yep.
Did I jump the gun?
Oh, you didn't. I just realized I didn't stop sharing.
Oh, okay. Next up is Chris Sagsveen presenting asset management tools for local governments.
All right, thank you. Okay, thanks for everybody for being here and this opportunity to discuss this topic today. My name is Chris Sagsveen, as you've heard, and the title of my presentation is Asset Management Tools for Local Governments. And I'm going to be sharing some QR codes today. If you're hoping to access any of the reports or anything, I just want to give you a heads up. So let's see here. Oops, sorry about that. I guess I'm actually missing a slide, but so this topic is basically the project deliverables for this topic I'll get into, and then I also have a guide for local agencies in Minnesota, a secondary one that I'm going to touch on after. But before we get into it, I want to talk a little bit about the LRB. So I'm sure most are familiar, but the LRB was established in 1959 by the Minnesota legislature, and they provide 0.5% of previous year's state aid distribution to cities and counties. And the purpose of that is for academic research related to not only strict research, but implementation research. This program is unique to Minnesota, and it provides a chance for city and county engineers to offer up new ideas for new research and implementation projects. And there was about $4 million available in funding last year. And that supported 25 new projects, and there's currently about 75 projects underway. So the board itself is represented by 10 members, and the committee, the Research Implementation Committee, has a similar structure, and both are supported by MnDOT staff. So each year, new project ideas are submitted and ranked and voted upon, and that's how this particular project came about. This slide shows the Local Road Research Board itself. Lon On from Marshall County is the chair, and their focus is specifically on addressing research needs of cities and counties. And as I said, they are supported by MnDOT staff, Ben Worrell from the Materials Office, and Jackie Duran from Research and Innovation at MnDOT support them. This slide is the Research Implementation Committee. This is chaired by Will Manchester of Minnetonka. There's a couple changes. Fausto from MnDOT District 6 was recently replaced by Nathan Gannon of District 4. Dave Conkle from MnDOT State 8 is off the board now, hasn't been replaced. And Dave Glyer supports the team. But as I said, they really put research into practice. And this project in front of you today was a Research Implementation Committee project. SRF's role is the prime consultant for the RIC, and Stonebrook Engineering does projects as well. So regarding the project, this particular project was looking for ways to calculate and communicate the cost of maintaining an average road using a life cycle cost tool. And then there was the goal of implementing an update and earlier LRB report on the use of GRIT, and that's the Geographic Roadway Inventory tool. I'll talk about that in a minute. As the project advanced, there was some modification to really help people expand their learning and understanding of GRIT through a development of frequently asked questions and some very simple, quick training videos to help support the understanding. The bottom line is really just to make it easy for city and county staff to get started in asset management at their agency and have the tools to put it together. So GRID itself is a web-based roadway inventory tool designed to help counties manage their roadways, minor structures, and signs. It's web-based in its approach. It was developed by the Upper Great Plains Transportation Institute at NDSU. And it was initiated in North Dakota and expanded to surrounding states. Now it's used in about 20 rural counties in Minnesota. And because it's a good starter pavement management software for rural counties, the Minnesota County Engineers Association Board of Directors recommended its use at their meeting in May of 24. And I know that there's a few counties who have been using it for many years now. So I think as a whole, if you're in a rural area and you're familiar with others using this tool, it's creates a great network of users. So the purpose is to really help county or city agencies collect, manage, and analyze roadway asset data, primarily for inventory, planning, decision-making of transportation infrastructure, because it's focused mainly on pavements and minor structures and signs. It does include a module for construction planning, but it wasn't really set up to manage other elements such as storm sewer or underground utilities. So larger agencies that are in urban or suburban areas would most likely benefit from a more sophisticated product. So GRIT can help counties, as we said, identify and track roads in poor condition, forecast pavement performance, review past maintenance and construction activities, and plan and prioritize future projects. So if you're like me and you like visual outputs, it's great. There are two great maps, graphs, dashboards that can help with trends. This is a PQI graph that shows some trend lines, gives an example of what it does. So a little bit about the technical advisory panel. This panel really helped shape the desired project outcomes. Lyndon Robjent was the chair at Carver County. There were multiple agencies involved, as you can see, and the team provided a good cross-section of input from city and county perspective. So if anybody's listening today who sat on this, thank you for your help in making this project become a reality. When it comes to the project goals and deliverables, I've touched on this a little bit, but there's a life cycle tool, which is a downloadable spreadsheet where cities and counties can calculate the cost of maintaining an average road. I'm going to share a little bit more about that in a minute. There was a survey that was done, a statewide survey, and the team learned from about 23 counties on what would be helpful for them to get going with grit and asset management. So from that, the team developed a list of FAQs based on common questions and 3 new videos. There's a grit overview video, getting started with grit and making decisions with it. So it was just a really simple way to get started. I know the web page for the program itself also has some other training that is helpful for folks. All right, so this page for the project, this is a snapshot from the page at the LRRB site. And there's that QR code that I referenced earlier, the project page. If you're looking for these deliverables and you want to learn more, you can use that QR code to get to the page. And I'm also providing on the bottom right a QR code and website address to the Upper Great Plains Transportation Institute at NDSU. It'll take you to that. And along the left, you can see those final deliverables. Those are just links that you can click on and actually get to work using that. This life cycle cost tool, as I said, this is just snapshots from it, but it's a downloadable spreadsheet. The yellow cells that you see are, they represent areas where input's needed from the user. There's some default values provided, but given that information and costs change over time, you'll just need to be aware of the values in there and provide updated information as needed. Just some basic information here. The units change if you are a city versus a county, so that's just something to be aware of, because cities are set up by square yard, I believe, piece, and counties by lane miles. So there's an instruction sheet provided on the page. You can enter inflation rate details, because the program can calculate up to a 30-year life. The user gets to add the type of treatments to use within those 30 years and those associated costs. So then at the bottom, you get total cost over the life of that pavement, and as well as annual cost. So, okay, so this slide, I'm not going to go through all these questions and answers, but it really is there to show you the types of question and answers that are available if you were interested in more information, all the way from what is grit down to how to use it, how where guides and training are available, and so on. Okay, so then I also mentioned that there's another resource out there. It's been out there. It's on the LRB site again, and it's a guide for local agencies that's been out there since 2019. It's an interactive guide with a summary document, and it's the purpose of this was again to help anybody who's new into asset management get started. And there's a checklist to use. There's it walks you through background of asset management, software and data, life cycle cost analysis, risk management, a lot of high level things that just help with the understanding of what truly is that asset management, how can I use it, and so on. So that's what I had today. It's more of a where to look and how to understand what's out there from an LRB perspective. I provide my email address if anybody has any questions they want to get to me after the fact. But at this point, I'll turn it back over to Stephanie and help answer any questions if there are.
Thank you, Chris. That was great. It was great to see different angles of the asset management process and way of thinking. See, is that showing? Here we go. So thank you to our presenters today. We have a few minutes left for questions, actually more than a few minutes. So if you have a question, please either put it in the chat and I will read that aloud for the record, or if you prefer, please raise your hand and you can ask your question directly. Any questions for our presenters today? If not, I have a couple to get us started. Well, for Başak and Joel, I'm wondering, based on the benefits justified by your research, are there materials or methods of preventive maintenance that excite you, that are on the horizon, like the next wave of strategies that would be maybe funded or explored because you've demonstrated that there's a benefit?
I can jump in on that first. We are looking at, I guess we've done recently several years of studies on different pavement preservation treatments. And so we have initiated looking at a cape seal, which is similar to, or is basically a chip seal covered by a microsurfacing as another option in our toolbox that we really haven't used in the past. So that's probably the number one thing we're looking at. But there's several items that we're looking at as a result of this study. And then, moving forward, how do we implement, the items that Başak presented? So that's what I have for that.
And I think something I'm excited that this study added to the literature is the findings on the timing of preventive maintenance and the frequency. I mean, with asphalts, we see significant improvement with 2 p.m. and we also were able to capture which treatments, which combinations. I think there are quite a bit of comprehensive data analysis that will give some input to MnDOT, as the asset management and payment management is an ever evolving, continuing effort. So we hope that with this research we were able to add to the toolbox for the already existing great practice at MnDOT for asset management.
Stephanie, you're on mute.
Thank you. Thank you for those answers. From Clark Moe, there's a question for Chris. Are there any plans to bring grit into Minnesota township organizations?
All right. Well, hello, Clark. Good to hear from you. Yeah, I'm not aware of any organized plans to bring grit into the Minnesota townships, but I do know that I think it's a good question because I feel that this would be a great starting point for townships as well. So it's a good question. I could look into it a little bit, but I have not heard that as a next step since LRB's focus and funding comes from cities and counties. So,
Thanks, Chris.
yep.
And then I have a question for Kristie. Do you have plans to share your data sets with GIS or transportation planning or civil engineering students? 171 miles of sidewalk and 12 sites sounds pretty enticing for someone who's studying these subjects.
We haven't considered it, but if there is a need, we can certainly make it available. There's everything is shareable.
Great. And then for Chris, I have a question.
Okay.
So does input from local practitioners simplify the development of asset management tools or add complexity based on the specificity of their input from the onset?
Well, hopefully this answer helps your question, but I think that, in my experience with asset management, you want to use the type of data that really helps define your scope of work needs, whether it's your projects or programs. And you can almost get too much data to not quite know what to do with all that data. And then when you have more than you need, you're asking yourself, well, how do I keep that data relevant, fresh from year to year? So you want it to be definitely good data and data that's necessary for your projects and programs, but nothing that's going to be too much to overwhelm your own efficiencies. So does that help?
It does. I know that I like nuts and bolts and details, but sometimes there are too many of them at hand.
Correct.
And I just had a question for all of you. The blessings and curses of doing this type of research in a climate with such extremes. Certainly we can be a model for other areas that experience similar winter weather and extreme summer weather as well. But what are the benefits of doing this research here in Minnesota versus elsewhere throughout the United States or elsewhere?
I will maybe jump on this. I think one great thing, so I have been with the state, with the university, this is my 7th year, and I was in Iowa before, and I have done a lot of data-driven asset management modeling work in Midwest. I think one thing unique to this area where we live is, yes, winters may be harsh, and then we need to deal with that, and that has impact on our infrastructure. And I think that's why maybe in this corner, we are also very aware of the value of taking care of the infrastructure. So I think I feel like I have been lucky that this type of work is prioritized here. And hopefully all of these are adding, I mean, to me, the awareness is very enabling for great work that we all are trying to do. So that's kind of my take on that.
Kristie or
Could
Chris,
maybe-
did you have? Okay.
I could just maybe build on that quickly. I agree. I think it's nice being in an area where multiple agencies are seeking the same type of proactive approach through asset management. So from regionally, I think Minnesota has a lot to offer, that you have states, cities, counties, everybody seeking the same sort of approach and trying to find some common understanding there. From a climate perspective, for sure, we what we learn through surveys and other things. It helps to know what other states and agencies in the Midwest or upper Midwest are doing or how they're approaching things. And I think Minnesota also sees just about everything. And so they maybe have that in hand. But I guess I sometimes have wondered, how do some states like Florida, who are exposed to a lot more salt and marine life, handle it compared to us? So
District one. So,
But they,
Yeah, Mr. Joel, I can build off of that too. Or do you want to take Julie's question?
Well, does your answer pertains to the climate and locality
Yes.
of Minnesota? Yep, I think you can go ahead.
Okay. So yeah, I've been fortunate, in my role to be involved in a national pooled fund that is looking at, we've got 20 states involved, and we are looking at that environmental piece of, our preservation treatments, and we range from, Alaska down to New Mexico, Minnesota, out to the Northeast, Southeast. So we've got all the areas covered, the moist freezing, the moist warm, the dry cold, all those different environments. So it's interesting that we're all, I guess, taking a pavement preservation treatment and then looking at how the environment affects it. And then all this is being taken into consideration, and I guess through the National Center Asphalt Technology, they developed a tool to help pull all this data together and analyze it. So it's we've been working on it since 2012. So we're 13 years into it. So it's really been a fun project. So yeah, it's all good.
And Kristie, did you have any thoughts on the topic of geography and with this research?
essentially what I put into the chat, the reality is that we see a broad enough spectrum that most of the models that we have are a good proof of concept that can be scaled just about everywhere, even if we aren't seeing those extremes. The knowledge that the refraction rates give us a good understanding of how something is deteriorated can be applied anywhere, but we had enough of a laboratory to have impacts. So,
Yeah.
Excellent. And Julie,
Yeah, I have a question for anyone on the panel that wants to answer. In thinking about this research and savings, are there things you would recommend to a city or county professional or state professional in making the case to their organization that they pursue preventive maintenance or their work in a way that saves money or makes sense for them, knowing that you always have to weigh what you're spending against the work that needs to be done?
I can respond to this because this is dear to my heart. Thank you, Julie, for the great question. This is maybe 15 years back. I was one of the founding members of TRB's bridge preservation. In the management preservation community, I think for all assets, we have for a long time as experts in the field, we knew maintenance and preservation are important. We knew intuitively that these make sense. They are good investments on our infrastructure. But we also had the challenge of really putting a dollar value on it so that we can make the case. We can make the case for it. So I have been fortunate enough to get involved with certain projects with the DOTs and NCHRP and with the specific one. So I think one thing I would maybe share with the local partners is that there are now studies out there that have been able to show the value. And I think that does the work for anybody who is willing to implement these practices more in their toolbox. So hopefully that a connection is made. And I would say, I think any researcher, expert who is in this line of work is very willing to share. So I would say, don't worry and don't hesitate to reach out so that we can all collaborate on that effort.
I would like to speak to this as well because there's a little bit that's unique about the pedestrian assets. So if we're speaking broadly, yes, this model could help with dollar savings, but once we start applying it to the state assets, which we own and we're responsible for, but we delegate the authority of maintenance to the local partners, it becomes a bit of a mismatch because the reality is that these aren't as high of a priority. And we right now don't have a good understanding of how much intervention will add to the life cycle. But the only benefit that we are aware of is that, yes, you will manage your ADA liability a bit better. So it's a little bit of a tough sell in our state, given the way we've set up that relationship.
I can share a little bit. In my time at Hennepin County, we established, or more formally established, there a asset management system and approach around 2015 and 2016, which prior to that, you're taking things at almost like a worst first approach, fixing what fails, and there's a lot of unplanned repairs and dollars that go into that. And so over time, through the support of elected officials and upper leadership to establish, hey, let's do preventive measures earlier. It will save you, and you show estimated savings based on what you think will happen. But it's nice when over time what you've done has proven to be the case and you're spending less on emergency fixes or repairs than what you originally or in the past had needed. So I like the idea of tools that are available to help show the value. I think experience also can help show that, and enough agencies have experience to probably show their own trend lines.
I can wrap up then for the group here, but yeah, at MnDOT we've been, I guess we know the benefits that are out there, but that was part of our study, was to, how do we quantify that? How do we show it? And so I think we've gained some good ground there with this research. We also have been monitoring the last 4 or 5 years performance measures on some preventative maintenance treatments, with our crack filling and our thin surface treatments. And that's starting to show, the results that we were hoping for too, of, we are extending the pavement life, we are benefiting. So, we're starting to do it, but it's a slow process to change over that mentality, like Chris referred to, from the worst first to, let's have a more strategic approach to how we do things and take care of those pavements, keep the good pavements good. So, we're making effort.
Keep the good pavements good. I like that. Any other questions for the group? Well, if not, I think we can give everyone 5 minutes back. Thank you. Thank you for joining us today. We hope you'll join us for the next webinars in our series. We will follow up with you via email with a link to a recording of today's presentation, information about upcoming Research Radar webinars, and links to the resources we've shared today. This concludes our webinar. Thank you, everyone. Have a great rest of your day.